Hello! In this video, we are going to prove the following theorem. Let a be a real number greater than 1. Then for all integers m and n, if m is less than n, then a to the power of m is less than a to the power of n. Now in proving this theorem, we are going to be using the following preliminary results that we have established regarding integer exponents. First result, let a be a non-zero real number. Then for all integers m and n, a to the power of m times a to the power of n is equal to a to the power of m plus n. Second, let a be a positive real number. Then for all integers n, a to the power of n is a positive real number. And finally, let a be a real number greater than 1. Then for all positive integers n, a to the power of n is greater than 1. So now let's get into proving this theorem. To start with the proof, let's give ourselves two arbitrary integers m and n, and we'll suppose m is less than n. Well then, a to the power of n can be rewritten in the following way. We're going to take the exponent, add and subtract m. So then a to the power of n is equal to a to the power of n minus m plus m. But then applying lemma 1, we can split up the exponents. This is going to be a to the power of n minus m times a to the power of m. So now, since m is less than n minus m is a positive integer. And because of that, it follows by lemma 3 that a to the power of n minus m is greater than 1. But we know since a is positive, a to the power of n is positive. So then, since a to the power of n minus m is greater than 1, well, if we multiply the positive number a to the power of m on both sides of this inequality, you're going to get a to the power of n minus m times a to the power of m is greater than a to the power of m. So putting this all together, we say a to the power of n is equal to a to the power of n minus m times a to the power of m, which is greater than a to the power of m. Therefore, a to the power of n is greater than a to the power of m. Or in other words, a to the power of m is less than a to the power of n, which is exactly what we wanted. And that's it. So we've shown if m is less than n, then a to the power of m is less than a to the power of n. So we've proven exactly what we wanted. So this completes the proof. And so yeah, that's pretty much it for this video.